Hello, my name is Brandon Belcher, and this is my presentation on the biogeochemical cycling of boreal forests. Biogeochemical cycling is defined as the cycling of chemical substances throughout the biotic components of Earth. These components are the biosphere, lithosphere, atmosphere, and hydrosphere. There are 6 main chemical elements that make up most biological combinations on Earth. This can be easily remembered by the acronym CHNOPS. These elements are carbon, hydrogen, which is also the hydrologic cycle, nitrogen, oxygen, phosphorus, and sulfur. The carbon cycle in the boreal forests, up until recently, the boreal forest was considered to be the largest forest ecosystem carbon sink on Earth. However, tropical forests have recently shown to have a greater carbon storage capacity than previously thought. The North American boreal forests hold up to 30% of the Earth's terrestrial carbon. Fire accounts for around 80% of the change in Earth's carbon storage over the past 1,000 years. Fires are also a primary contributor to the carbon release in the boreal forests. Insect infestations kill trees, causing premature decomposition, while logging is responsible for a minimal amount of carbon release. Trees can burn or fall prey to insects and ultimately decompose. In either case, they release carbon to the air that was once held in those components. The hydrologic cycle. Most of the freshwater inflow to the Arctic Ocean is generated from the boreal forest, either by snowmelt or surface runoff from precipitation events. Due to the low annual precipitation in these forests, snowmelt is a primary source of surface runoff. Studies have shown that approximately 25% of the snowmelt water in boreal forests are taken up by deciduous trees, and around 0.6% of this water is taken up by coniferous trees. In non-permafrost areas, this water eventually infiltrates the groundwater aquifer for storage. In permafrost areas of the boreal forest, water is mainly stored in trees, while the remainder ends up as a surface water in streams, rivers, and lakes. Nitrogen cycle. In boreal forest ecosystems, nitrogen in the soil is the most limiting nutrient to the growth of trees. This is mainly due to the slow rate of decomposition in these ecosystems, as well as a low amount of available mineralized nitrogen. In undisturbed boreal forests, the nitrogen cycle is generally closed. Most of the available nitrogen is recycled within the microplant system. The nitrogen cycle is often disrupted due to logging, fires, and by the use of fertilizers for agricultural purposes. In the past few decades, the atmospheric input of nitrogen has increased due to emissions from combustion processes, such as vehicles and other motorized equipment. The use and production of ammonia in agricultural processes has also increased the atmospheric input. Oxygen in the boreal forests. While the boreal forest remains a primary terrestrial carbon sink, it continues to be a key player in the production of atmospheric oxygen. As previously stated, however, if the boreal forest continues releasing more and more carbon to the atmosphere, either by fires or rapid deforestation, it may begin producing more carbon than it can convert to oxygen through photosynthesis. Phosphorus cycle. Like the nitrogen cycle, the phosphorus cycle is also a closed cycle in the boreal forest ecosystem. Slow decomposition rates of plant litter also affect the phosphorus cycle, as well as the removal of trees by logging operations. Since decomposition rates are delayed due to the climate in this ecosystem, the phosphorus recycling cycle takes much longer than in other forest ecosystems. In agricultural controlled areas of the boreal forests, fertilization also has an impact on the nitrogen-phosphorus cycle through over-fertilization. And finally, sulfur. Like nitrogen, most of the sulfur found in the boreal forests is located in the soil and decaying ground litter. Acid rain is a devastating issue in these ecosystems. In industrialized areas where the burning of fossil fuels is less controlled, the emission of sulfur dioxide to the atmosphere in turn forms sulfuric acid through reactions with water. This acid rain in turn damages trees, which makes them more prone to insect infestations, which also affects the other biogeochemical cycles covered earlier of this ecosystem. The soils and surface waters are also greatly impacted by acid rain events in the boreal forests. And that concludes my presentation on the biogeochemical cycles of boreal forest ecosystems. Thank you for watching the presentation.